Good day, everyone. Good morning, good afternoon, and good evening. At Silicon Valley, we are Chris, Emezue, and Bonaventure Dossou, and we are very glad to be giving a talk at the Bay Area NLP. The title of our talk will be Advances in NLP for African Languages. Yeah, a brief biography about us. Bonaventure Dossou is a master's student at Jacobs University, Bremen, and he is also a research intern at Mila AI Institute. His research areas include machine deep learning, and especially his applications in computer vision, NLP, and healthcare. About me, I am a master's student at Technical University of Munich. I'm studying mathematics and data science. I am a working student at Siemens too, and I am also a research intern at Miller. And last but not least, both of us are working on what we call Africa NLP at Masakani. Africa NLP is, I would say, a movement to promote research in African languages. That's just a simple way to put it. So when we look at the world today, there have been lots of development and improvement in NLP for high resource languages. We look at translation, we look at natural language understanding and generation, we look at speech to text, text to speech. There's so many systems, translation systems, and language technologies out there for other languages. But unfortunately, when it comes to African languages, there is little to nothing being done. Well, at least there was little to nothing being done in the last decade because recently, in the last couple of years, there have been a surge of researchers in African languages. Most of these researches are by African researchers, but most of them are by non African researchers, just with a vision of trying to democratize um, NLP for African languages, with a vision of trying to incorporate these African languages in these language technologies, with the vision of bringing Africa to the NLP map, as we put it in Masakani. So today we will talk about one of these many researches, one of these many systems, one of these many efforts towards putting African languages on the NLP, specifically two African languages, which are our native languages. So my native language is Igbo, and Bona's native language is Fon. So today we'll be talking about FFR Translate, Font to French Neural Machine Translation. We'll be talking about Okube, and we will be giving a brief intro to Masakani. So for FFR Translate, we have a website, ffrtranslate.com. It's already there. Africa occupies about 30% of the world's languages. I mean, the next competitor we have is Asia. But the interesting thing about African languages, it's not just the languages, the language families that you know. It's also when you go deep, there is many more variants and dialects of the same language. And these dialects may not be similar. For example, Fon has about 53 dialects or so. We will see in the next slide, and Igbo has its own dialects too. So there are interesting morphological and linguistic components of African languages that present their own challenge in NLP. Some of the issues facing NLP in African languages are there is this lack of data. That's the major thing. You don't find enough data on African languages like on the internet, like you do for English or German or French. Lack of reproducibility. So some of these researchers that do researches don't get enough, you know, discoverability as they should.
Recognition.
Yeah, and recognition. Thank you, Bona. So, for example, many of these high tech conferences don't um, will readily not accept a paper on an African language, dismissing it as not innovative as is normal. To circumvent that, there have been a number of conferences and workshops like We NLP and the Africa NLP workshop that just recently took place that help to promote discoverability and recognition of African researchers. Moving on, next slide, please. So moving on, I'll give a little um, direction so you kind of know how these African languages are grouped and how, I don't know, segmented they are, I can say. So for example, we're taking Fon and Igbo. So you have this parent of Niger Congo, you come down the ladder, Atlantic Congo, you come down and you come down until you reach the Bay clusters, and then you have Fon. And just slightly after the brother of the Bay clusters, somewhere down, you find Igbo. Bonaventure would talk about the data sets used for our FFR project and the model.
To build our FFR project, we, like Chris mentioned, lack of scarcity of resources. So to start our FFR project, we first of all seeked for data. And the dataset we built, we had two versions that finally has been merged to get one version. Initially was two versions, and we call them FFR datasets 1 and 2. The major sources were Jehovah Witnesses 300 and Benin Long, containing sentences, proverbs, and also some books of the. So from the first version to the second version, we've mainly registered like incomplete, incorrect, and sometimes inexistent translation or some mismatching between the sentences. So we had to include the foreign French natives or speakers to do some kind of human evaluation that is also a huge strain actually that is actually important. Like we have to make that effort to include the people speaking the languages into those technologies that we are building in those languages. So the like you can see on at the lower right corner, the data set size drastically decreased, but we believe that it increased in quality, and that actually indeed it did increase. And the next slide showing the result actually confirmed that. So we wanted to make a kind of proof of concept. So we started with the basic encoder decoder architectures. We use mainly RNNs to be much more specific, GRUs, and we incorporated the so-called additive or Badano attention. So this somehow proved that, okay, we got less sentences, we got less quantity, but then we gained in quality. And the final version of the dataset that we use to have our FFR is more of the, we still filtered the FFR version 2, including more people and also shifting the focus from biblical domain to much more daily dialogue. So to do that, we look for people, we created surveys, and then we shared on Facebook, social medias, and everything, and we gather people sentences from people that speak the language, speak foreign language. So so I briefly already talked a bit about how the FFR dataset has evolved. Then the current model that we have is still like a RNN configuration. So next we want to explore monolingual data that has been proved to increase the quality of the translation. Also explore data augmentation for low resource languages, and of course the state of art of NLP machines like the transformers. But also we want to explore other technique tokenization methods like the web word expression based tokenization that we recently presented at African NLP at ESCA 2021. So we invite you to go and read that paper, and it really helps us to increase the quality, and our FFR currently that we show on the next slide is based on that web tokenization. So now we've moved from font French and French font. The next step is to move between African languages. And we want to start as two native speakers of Fon, respectively Fon and Igbo. We want to start working on Fon and Igbo. So, like Chris mentioned, we have the website that is already publicly accessible, and like you can see, where we you can type your sentence in font, and we also, for the difficulty of typing, we created also a keyboard that is available on the Play Store, Google Play Store. So you can type a text in font and have the translation in French, or you can type your translation in French and have your sentence, sorry, in French, and have your translation in English, in font, sorry. Sorry, English. So to make it much more fun, we added like the surprise me, which automatically generated some sentences, and according to the language that has been selected, according to the language that of the source language, we have the corresponding translation back down. And you can see that we've been playing with French and font translation, and now we are playing with font translation, font sentences, and French translation. So that being said,
We also have the go back, Bonner. Let me also, does it start from the beginning? We also have the suggest translation functionality where you can suggest a translation. If you play the video, Bonner, you could see the or you could suggest a translation, and this it was put there to help. You can leave it from there to help gather samples for that the model will not may not be able to translate because it's not, it's very far from the standard model that can translate almost anything that we're aiming for. But we want to we release the website and the model that we have now so that people could use it, and the community can also suggest translations, especially since we are driving towards getting um, conversational type translations and way of talking in fun. So, and here is typing in Je m'appelle Bonaventure. And when the FFR came out in the workshop, African NLP workshop at ICLR, I clear 2019, right? So, 2020. 2020. Sorry. Yeah. Thank you. So we had a feature from BBC News, and it was a very, yeah, it was a very big thing because seeing that the work that we're doing was getting this much attention and this much accolades and praises was really, really great. Now we want to go bigger and expand more. And one major place we want to expand towards is African multilingual machine translation. So for this, definitely we'll need resources and donations. And so we're calling on any and all form of donation. It could be research collaboration or idea sharing for the future of FFR Translate for African languages. Next, Bonaventure will talk about the next part of African languages, which includes speech, because as much as many things are being done on text, you have text machine translation, text NL, natural language generation, and natural language understanding. The future of African languages lies in its speech because if you look at the history of many African countries and African culture and the way values are passed down, it's through speech, it's through music, it's through, audio forms of passing down information and communication. So Bona will talk about our work on Okube, which involves speech.
so thank you, Chris. That was a nice introduction. So I will introduce and we will talk about our end-to-end speech recognition for fun and for Igbo. So Okube comes from two words, Oku from Igbo, which means speech, and Be font, which means like languages. So putting Okugbe together means speak the language, and it is an initiative like Chris announced because we believe that the future is in speech for African languages. We have griots, we have people that are working, even the grandmothers or grandfathers that are back in the villages. They are not used to cell phone. They talk, they speak. So that will be the next major challenge that African languages will face. And we already started working upon that challenge, introducing Okugbe. So yeah, going along with the with what I've just said, what we just said, there is Nelson Mandela, very well known, that said that when we talk, we speak with someone or to people in the language they understand, for instance, in English or Spanish, whatever, they will understand it. I mean, with the brain, with the head. But then when you talk to them in their languages, then it goes to their heart. And I have that thing in my language in phone that says, "Nueve numero dodo." Like, what is meaningful, what is dear to your heart, you only can express it better in your mother tongue, in your language. So that's one of the motivation. That's the main motivation. And like we talked already about the open challenges. So for instance, here actually at the date we are doing this recording, there are very, very, very little research, like Chris already said before, on automatic speak recognitions on African languages. It is important to note that those languages are most likely tonals. And because of that character, if we add the morphology and everything, it makes it much more challenging, much more complex. But there are no or very little research done about that, about ASR, automatic speech recognition, for those African languages, which poses a problem because we talked about machine translation for African languages, but then there's also the speech part. So they follow each other, they go along with each other. And then we want to tackle that issue. So the main challenge for us here was to create uh, automatic speech recognition systems that will be able to understand the African languages, concept, grammar, morphology, and everything to faithfully translate what, for instance, the grandmother of the village will be talking about to maybe to her son who is living in the United States, or maybe who's living in China, or maybe in Germany, like us, and everything. So this will ensure that we preserve those languages, because if we encourage those grandmothers, the young to speak their own native languages, it will promote those languages, which are already almost close to extinction. They are endangered. This will also ensure that we are making sure that AI technologies and models and everything are used for the benefit of everybody. So it's not that one language like English, actually we get the whole trend, we get the whole focus, we get the most of models that have been produced. Like we talk about BERT, we talk about GPT, but we're not having those one in those African languages. We need it to. And like what Yongo said, if we don't do it, Africans, nobody will do it for us. So the contribution of our paper was, first of all, to give a very big, detailed overview, linguistic overview of Fon and Igbo. And Chris will talk about it soon. We created two ASR models for Fon and Igbo. For Fon, there was a unique work done by Dr. Laleye before, and our work has outperformed the performance of that model. So for Fon, we present a state-of-art ASR model, and for Igbo, we present a benchmark result. The other thing is we recently also took part into the sprint, of Hugging Face using the Wave 2 VEG, I think, and we achieved a better, even better model that we will introduce in we'll talk about in this talk. We achieve a better model that is actually available on the Hugging Face model repository, and you can interact it with already. You can record the speech and then already have the transcription. So yeah, after till now, let's Chris go ahead with the transcriptions and the morphology and everything related to background.
Okay, thank you very much, Bonaventure. Before I go into talking, I just want to highlight the artworks that you may be seeing in the presentation. So Africa is known for, yeah, African art, which is a special form of art portraying some African traditions and cultures. So we decided to spice our presentation by also putting some of these very inspiring artworks by some very inspiring artists, but that's just for you to, that's just for your eyes. Okay, the linguistic backgrounds of Fon and Igbo. As Bonaventure said, um, we performed the linguistic analysis of Fon and Igbo because to go into ASR, to go into speech to text for these languages, it was very important to understand the nature of these languages. So, for example, African languages we know are tonal. Some languages are very tonal, while some languages are not. So there's like varying degrees of tonality. There's also varying alphabet structures. And so these are some of the reasons why we perform this analysis, because we believe that this is the first step to understanding these languages before creating a language technology for the language. So the full analysis is in the paper, but for the purpose of this presentation, just a brief summary. There are some similarities between the languages. For example, they're both tonal. They have dialects. Fon has 53 dialects, and Igbo has about 30 dialects. And they have some differences. For example, the major difference is in the code switching. Fon does not have code switching, while Igbo has extensive code switching. So, as a matter of fact, there is about four types of code switching that Igbo bilinguals perform or they do while speaking. Next, we go to the copper. Um, as for any machine learning model, it's very important to have the data set. For the Fon copper, we collaborated with a researcher, Dr. Laleye, who had gathered in the past gathered some fun speech with their transcriptions, about 10 hours of speech by 8 women and 20 men, natives with the very good sampling rates and average length of 4 seconds. So, and by making this data set open source, it was very easy for us to pick up on this research and compare with his own model. On the other hand, for Igbo, unfortunately, to the extent of our knowledge, there was no open source Igbo speech data, not even in OpenSLR or anywhere. The dataset was finally got from the LDC Linguistic Data Consortium, Pennsylvania, the Igbo Language Park. It was licensed, and we bought the license. It was not open source, and the license mandates like not sharing it, which is not good. Another interesting thing here is for the font dataset, and first of all, for our research, one major thing we wanted to do in our research was to look at the impact of diacritics in the ASR model. So for the font corpora, the diacritics were there, but for this Igbo corpora, the diacritics were stripped off. Important to note that due to this problem we faced, unprecedented problem we faced gathering the Igbo corpora, we have now started working on getting Igbo speech dataset. As a matter of fact, we are collaborating with some researchers in Nigeria to record some proverbs in the audio and make it open source. And from there, we also want to have a platform where the crowdsourcing for Igbo audio dataset and their transcriptions. For the text, that's the handling of diacritics. So good. You see this example here. It shows how one word in Igbo or Fon could mean different things with different diacritics. So like with Igbo, you have aqua, 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 and with Fon, you have to, to, to. How do you say the country, Bona?
To.
So, thank you. This research was partly about showing the importance of having the diacritics encoded in the data set that you're training the model with. Next, we go to the models and experiments, and I believe Bonaventure would take it from here.
So yeah, here we tested three different, I mean, four different models that are mainly made of residual convolution networks, bidirectional RNNs, LSTM and GRUs, and the additive attention of attention mechanism. So, like you can see, we had four model stacks like RCN. All of them contain the RCN because basically because the input features were spectrograms, so they were like kind of 4D, yeah, spectrogram that have 3D pictures. And we tried different variation of with by GRUs, by LSTM, and then we combine both of them, like LSTM first and GRUs after. Like it's usually done for translations, I mean neural machine translations, and on the decoder part, I mean on the BGRU part, we included now the attention mechanism. So here's a little brief overview of the model or what it looks like. We had our inspiration from deep speech from Baidu. So I think we'll have much more detail of everything and even how we implemented, we customized somehow the attention mechanisms to make it work here in our paper. And of course, we use the CTC loss at the end to evaluate how well our model was performing. And so moving next to the results, our metrics, we use two metrics, the CR and the CR, which is character error rate, and the WER, word error rate. So as we can see, the best result have been achieved both for Igbo and Fon when we use the combination of the residual convolution network, the combination of both bidirectional RNNs, and we added the attention mechanism on the decoding part. I mentioned before another model that we have using fine-tuning the wave to VEG of Facebook, I think. We took part into the sprint of Hugging Face, and that model actually hosted on Hugging Face model repository achieved a word error rate of 14.90, which is way better actually than 42. And yeah, it's already available, and then you can play with it. You can go there, record your audio, and then play with the model. And the quality is quite good. Still, we are working toward reducing it. So next, here are some predictions of the model, and here we wanted just to point out why maybe we had some, let me say, such 42 is not a such a bad, sorry, word error rate, but we wanted, I mean, something that would be much more lower, because the lower the better. So for instance, we can see that in the transcription that has been gotten, we have the predictions and then we have the target. If we take the first example, we have Akpon, for instance, and we have Akpon. So in the speech, this is not noticeable at all to native speakers when they are exchanging messages and everything. But in the writing, we can see that there has been an insertion of an A, additional A. This could have definitely impacted the computation of the word error rate. The next example shows go sing. So we were expecting ghosting like it depends. I mean, ghosting has different meaning from it depending on the contents, like for context. So for instance, if you hear like fite a go sin huingbe, like where are you going to? Um, go sin a long way means maybe leave somewhere or something like that. So you can see that the target had some white space in between, but the prediction didn't have. And the last example was about the presence of the diacritics. We in the target didn't expect, I mean, we're expecting an ekpukpede, like it remains little, but pede without the diacritics asyntography. But the model predicted what's supposed to be the right thing, pede with the diacritics. Same thing for the last sentence. So yeah, the code to the model has been open sourced, and here are the links. I will let Chris carry on for some analysis about the performance of the Igbo model. Thank you.
Yeah, thank you, Bonia. You observe that on the for the font that there's a wide gap between the character error rate and the word error rate, whereas in Igbo the gap is a bit it's not as wide as in font. We did some studies to look into that, and our major finding we was that this is due to the character set of the languages. So the character set is the set of the, the characters that the model uses its training to predict during the transcription. So for fun, the character set, because of the inclusion of the diacritics, is the normal 36 or so alphabets plus the diacritical combinations for each letter that has diacritics. So that's really, it makes it really big. Whereas for Igbo, because the diacritics were stripped off in the beginning, so the diacritics were not used for the model training, the character set is just made up of the alphabets for English language. So um, this makes it such that the on the character level, on a character level, you can see the some slight deviations, like as Bona mentioned, the E with the accent, and then the E without the accent as a target, but the prediction is with the accent. Or in the next slide, next example, you see like with Gaussian. Next slide, yeah, with Gaussian, where like the Gaussian is the target is there's a space, but on the prediction there is no space. So on a character level, you can spot these differences, but on a word level, it looks fairly okay, and so this might be one of the reasons for this gap. And to take care of that, we believe that training the font model on more times, more epochs, because it's just 500, might help mitigate that. But that's an open research that we're working on for Kobe. So now we are done with FFR and Okube. FFR work on text and Okube work on speech for two of the 2,144 African languages. There are many people like us and many people inspired us also working on NLP for African languages, and one of such is Masakani. Met and joined Masakani, I think, in 2019. And funny thing, yeah, and before then, we were looking for organizations or people working on something involving African languages, and miraculously, we found deep learning in Dabara and Masakani. So there is many other organizations. There is Translation Without Borders. There are also key researchers like Jade, Julia, and many other researchers who are working on low resource languages, low resource African languages, and also in speech and other areas of speech and language processing for African languages. So Masakane is a community, an online community with the sole aim of putting African languages on the NLP map. That's just the easiest way to say it. It's for everyone, and the focus is on African languages. So it's not only for Africans, it's for anyone and everyone who has an interest on putting African languages on on the NLP map. We believe that it is our responsibility to do that, because if we, like, who are we waiting for? We can't wait for anyone else to do. We have to do that. So we, Masakani and everyone else, we're taking up the mantle of trying to apply these NLP techniques to African languages. Masakane recently got the Wikimedia Foundation Research Award of the Year for the paper on participatory research, which brought this concept of a participatory approach to tackling the NLP issues in Africa as a whole. We have about 700 plus members made up of experts, linguists, experts in different domains and computational linguistics and just pure linguistics of the language. We have native speakers. We have everyone is working together and working harmoniously towards this goal. Masakani is for everyone, so anyone and everyone can join Masakani. To join Masakani, just you can simply go to the website and you scroll down and you there's a link to the Slack channel, because all communication is made on Slack to help organize things. So you join the Slack channel and voila, you're part of Masakane. There is also, it's not just voila like that actually. There is like ways you can help, like you can contribute to your expert knowledge. There are many researchers, young researchers like me and Bonnet, to asking questions about the research we're trying to do and we need help. And there are many people out there. There's also, I think, Matthias from Salland University and many other, and this Professor Graham Newbig, who from CMU, and many other very wonderful, experienced researchers who are helping and giving their best to this project. As a matter of fact, for the work on Okube that we did, again, we didn't have access to computational clusters. Of course, our universities don't know or support this work we're doing because it's not part of our master studies. So again, we had to use Collab, and of course, with audio data, it takes a lot of memory. So Professor Graham had to pay for an Amazon instance for us to use, and that's one of the things that helped. It still was okay, but not enough. And the attention mechanism that we propose here, Bona had to restructure it in such a way that it does not keep and store, cache the memory and the values on the GPU. It has a way of delete, removing them after the calculations, just so that we could have salvage the little resources that we had. So these are the works of the dynamic dual Chris and Bonaventure, inspired towards machine learning, NLP, and trying to do something for African languages. We are part of Masakane. It's a bigger community of Africans and many people who are also inspired towards putting African languages on the NLP map. And so, with this, thank you very much for our presentation.
All right, Bon and Chris, thank you very much. That was an incredible presentation. I am really impressed with how much was covered in what I think is applicable to so many NLP situations. Thinking about dialectal variation within languages, um, uh, thinking about tone, which is so ubiquitous and often ignored by people only focusing on a small number of languages, right through to things like character encodings and finding that there were no diacritics in existing corpus. I've been in exactly that situation before. Yeah, so I appreciate you sharing all of the real hard work that goes into creating good linguistic resources. So with that, I would love to open it up to questions, and Bon and Chris will manage the questions directly. Please ask them in the text Q&A, and if you don't want your name to be read out or you don't want to speak, you can just let us know in that text box, because this has been recorded, just as a reminder. All right, and with that, I'll turn it over.
Okay, I can start, and we can share it, me and Bona. Um, okay, I will start with a question from Dave. Chinese is also a tonal language. Could air some orders for Chinese be used for African languages? Yeah, this is an important question. We haven't tried it yet, but I think yes is the answer, because while I was trying to learn about the tonal analysis of Igbo, I stumbled on a paper that was actually comparing the analysis of Igbo and Chinese, and trying to the paper was just trying to compare them. And I think working on that idea, some of these ASL models on Chinese, I think, could be used for African languages, for Igbo specifically, I think, and for other Tone African languages. But that's a very important research idea to try. And okay, how large was the how large was the AWS instance for this? Um, um, the AWS instance was really not large. I don't remember the exact value, but that um, I remember that with the AWS instance, it was only possible to work on Igbo, and it was pretty slow. It was only possible to work on Igbo. So for the fun, Bona still had to use Collab, and at some point, we still had to transfer the Igbo to the Collab because the AWS instance was quite slow. So yeah, I would say around medium. I don't really know the exact. I don't remember the exact specs of the AWS instance, but I think
The
they are in the
memory
paper.
was up to 100 gigs or something like that. The RAM, if I remember well. But yes, I mean, after we had to move to Collab because it was slow. Chris had a lot of data at the beginning, but then after we had to figure out why his what error rate was very low, sometimes giving any non-values. So we had to look through the data and then perform some data analysis. That's what brought us, I think, from almost more than 10 hours of recording to just 2 hours and 2 hours and a half hours of recording. And that's the part that we could actually use in the Collab. We have had to update Collab, I think, use Collab Pro and everything. Yeah. Yeah. So any other question? Please come up with your question.
I have one while we're waiting for more people to write them into the Q&A. So you said that a lot of this work wasn't really part of your master's programs. Now that, unlike most master's students, you've published many papers on this kind of research and received recognition. Are your universities proud of you as master's students, and are they giving you more space to do this research?
Okay, so I'll go ahead first. From my side, it was way better. Yeah, because my university really uh, gave us recognition, like they help us to have much, for instance, much more media coverage and everything, like interviews with newspaper, with Deutsche Welles, with Tages de Monde. I mean, those big um, TV channels of Germany. And yeah, because also of that, I've been recently awarded the Community Award for Innovation and Diversity, something from my university. From Chris' side, I haven't seen anything, so I don't know. Maybe he will take it up.
It's pretty interesting the team. Well, yeah, they are proud of us students. It's just while Bonnet is an international university, TUM is a it's it's not an international university, and it's like the whole of Bavaria, and it's like so many students. So yeah, they are proud in their own way, I can say.
I'm
Um,
glad to hear that. No doubt. Looks like there's another question.
yeah, we have a question from Dave. Have you con I should read the question. Okay. Have you considered collecting a big data set for an African language and creating an image net-like competition for it? Now, this is beautiful. This is wonderful because this is what I was me and Bona were talking about after we came to the shocking discovery that not many African languages do have data sets and also like a centralized data sets. We checked OpenSRL. We started working on a way to bring these African speech data sets together in, I like the word, ImageNet like fashion. And about the creating competitions for it, to be honest, I didn't think of that far. I just thought about having this ImageNet like database where that's, it's purely for African languages. So it's very easy to just go in there and find your African language that you're working on. So this has led to works like the audio platform that we're working on. This has also led to another platform called Landfrica that we're working on, where we're trying to create like a database repository on all things related to African languages, the data set, the models and stuff like that. So yeah, the answer is we have thought about it, and we are working on it. And also with Masakani too, we're working with Masakani on bringing together resources and research that has been done on African languages. While it's still on NLP and the text part, we're pushing for work on speech because it's high time we went into speech.
Yeah, so there's a question like many African languages tend to have, actually they don't tend, they have many dialects. So for France that has up to 53, something like that. Yeah. Did you encounter this in your analysis, and how do you deal with differences between dialects? I think we encountered that problem. Yeah, we encountered it when we were working on the FFR data set. And what we just did uh, as we could back then was just to involve or to include the a lot of variety of styles of dialects in the data set. So we talked with people, we found speakers from many regions of Benin. So the form that people from, for instance, from the north we speak won't be the same as the form that the people from the center will. And as a matter of fact, I attended when I was in Russia. I had a friend who was fun speaker, but then sometimes when he spoke, I could not understand him. So we made sure that we reach out to a lot of people and have those the suggestions, the sentences included in the data set. Yeah, that was basically what we've done so far for it.
And to add to that, this a general research, the things that are done when it comes to like these multi-dialectal languages. So these languages have different dialects, and somehow they also have what they call a standard or a central dialect. So in order to help make the research reproducible and for other reasons, many researchers like just stick to the standard dialect. So if you're creating data sets, you just stick to the standard dialect so it could be used in other areas. For the ASR, we particularly wanted to see the effect of different dialects on phone, especially because that's where the dataset creation had different dialects. And yeah, we have another question.
Yeah, go
Um,
ahead.
I see a lot of movement lately for larger African languages, but most African languages are spoken by smaller population. That's true. For example, in Cameroon, outside of the south of the country, languages usually have fewer than a million speakers. Yeah, that's true. I work with speakers of a large language with 400,000. Okay, cool. Where do you see these languages fitting into? Is it 400,000? I got it correctly? Okay. Where do you see these languages fitting into the existing work that you are doing with Masakani and others? It's very true that some of these African languages are spoken by a very small population, and that's one of the many reasons leading to the data scarcity. For the future of these languages in Masakani, the vision, the grand vision of Masakani is to include all African languages. It's quite an ambitious vision, you could say, but it's the grand vision, and I think it's possible. So even though there's a small population speaking this language, um, some of the, like, if for example I had a personal experience with a guy, a researcher, and he joined Masakani and he saw the work that was being done for people's native languages, what people were doing for the native language. He wanted to do something for his native language, and then he had a call with me. Now his native language is among the class that you mentioned. There's very few people, you could really count them, and he proposed what to do in that situation. And what we sat down and started doing was, we sat down, we looked at the language, and we started looking at ways he can connect with his people, I can say, with the native speakers there, and organize programs. So we thought of organizing essay competitions and stuff where because it's a societal problem. Actually, it's not something you just change in one day. You first of all have to get the society to begin to do things or use that language, and by doing that you're creating this data set. So we started brainstorming on ideas like creating a research competition. That's the Zinda that's been done, like the Kaggle of Africa, Zinda, and it helps to generate languages. So I believe that, for example, for the Zinda, there was a competition on Fon and Ewe, and Ewe is also falls in this category of languages with very small population, but with with um with things and systems like this, like Zinder, and processes that make people begin to use the language, begin to do things with the language. It would take time, but I see and I envision a place where these languages with small speakers will still be able to gain a place in language technology in Masakhane in general.
Um,
Okay.
so Bonaventure and Chris, thank you again so much for the presentation today and for answering the questions. I really enjoyed this. And like I said, I think you covered so many important areas that don't get talked about enough in NLP, like community-led data collection, right through to little things like encoding diacritics and making sure that the full diversity of a language is represented in the data. So again, thank you very much. I appreciate it.
Thank you, and have a nice evening.
Thank you very much. Thank you so much, everyone.
All right, and thank you everyone who attended. Like I said right at the start, we will have the Spacey co-founders next month, so stay tuned for more information about that. Have a great day, everyone.